Welcome to the Unit 4 Day 1 video on histograms and dot plots. Let's say you were a quality control person at a candy factory. Your goal is to see whether there is an equal amount of each flavor in each bag. Here's a sample of 20 bags of Skittles. You counted how many green Skittles were in each bag. So you open the first one up, there are 15 green, the second bag had 9, and so on. These are the number of green Skittle candies in every bag, and you had 20 of them. Now you need to present your findings to the quality control team. So the first thing you need to do is label your graph, and this is important. Your graph needs to have a title, and both axes are labeled. The title would be the number of green Skittles in 20 bags. Okay, and then on the vertical axis, I'm going to write the number of green Skittles. I'm sorry. I'm going to put number of bags there. Number of bags. And then this is going to be the number of green Skittles. Down to the bottom, number of green Skittles. Alright, so the first thing we want to do is figure out how many bars we want to have, how many intervals we want to have. And I see that the lowest number I have in a bag is 8, and the highest number I have is 21, I believe. So let's say I want to have 6 bars. Let's just start with the lowest number, and we'll go from 8, and we'll go up to maybe 11. And then we'll go from 12, and we're going by threes here, so 12 to 15. Then we'll do 16 to 19, and then from 20 to 23. Now let's tally how many are in the first interval from 8 to 11. So there's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, let's do the next one. Then we'll go from 12 to 15. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, the next group, we're going to tally from 16 to 19. All right, so here's the next one, 16 to 19. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. And finally, we'll do one last group from 20 to 23. 1, just 1. Okay, now what we need to do is set the intervals down on the axis down here. So I'll label this, and this is from 8 to 11. That's my first interval. Then I go to the second interval, which is 12 to 15. Third interval is from 16 to 19. And finally from 20 to 23. And I'll label my vertical axis with 1, 2, 3, 4, 5, 6, 7 was the biggest tally I had, so I only need to go to 7. So in the first interval, from 8 to 11, there were 6. 1, 2, 3, 4, 5, 6. And if I had more time and I was trying to be more careful, I'd make sure that this was evenly spaced. So you could see that there were 6. All right, in that first interval. And in the second interval, we had 7. There's my tall bar. Notice how I make sure the bars are all touching. That's important. All right, and since you don't have color, you might need different patterns, so you might need to go a different direction. All right, the next interval looks like I had 6 again. Oh, and I wanted this to be blue, actually. Okay, maybe I'm going to use dots instead of stripes. And finally, the very last group had only 1. And there you have it. Another thing to be careful of is that the number line should start at 0. And notice I started at 8. So I'm going to put a little broken line there to say that I had to jump from 0 to 8 pretty quickly. All right, and so then I have a histogram. This is called a histogram, also known as a bar graph. You can see that most commonly there were 12 to 15 green Skittles in a bag, and every once in a while you got a bag with a lot of green Skittles. Okay. Now, what percentage of bags had more than 15 green Skittles? Well, there was 20 bags, and more than 15 would be this, 6 plus 1. Those are all the ones that are bigger than 15, more than 15. There were 7 bags that had more than 15 green Skittles, right? We had 1, 2, I'm sorry, that was a mistake. I meant to circle the one next to it. 1, 2, 3, 4, 5, 6, 7. Those are all the ones that are more. And then what percent is how many out of 100? Well, 7 out of 20 bags had more than 15. And of course, if I divide in a calculator, again, I'm going to use a calculator. Let me pull it up here. 7 divided by 20, 35% of the bags had more than 15 green Skittles. Now you could have gotten there by multiplying this by 5 and made it out of 100. See, that's the same. We can make another type of dot plot with this data, which is called, another type of plot with this data called a dot plot. Again, I'm going to start with 0 and I'm going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And notice I'm trying to make these as equally spaced as possible because they are a number line. As I'm talking, I'm not drawing what I'm supposed to be drawing. I'm going by ones, so this should be 5, 10, 15, and then 20, 21, 22, 23, 24. That should be enough. But just know that this number line could go forward or backwards. In this real-life example, we probably don't have many going backwards, but that's okay. So let's count. The first one is 15. I'm going to put a dot right there. So made the number lines, evenly spaced. I'm going to draw the dots. There's 15, 9. There's put a dot there. 11, dot there. 16, dot. 21, dot. 12, dot. 19. And you can see that this is pretty tedious work, but it's not hard. You just have to go through and do it. Now I have my second 16. There are two 16s, so I stack them on top. 12, another 12, stack that on top. 10. And you can see that I'm going to get, in a way, another bar graph, but this time the bars will be made out of dots. You can see this gives you a little bit better picture of what maybe the most common number is, or how they are distributed. Then another 19 there. Another 8. First 14 and another 15. And you can see that it's sort of centering around this 15, and we'll talk about those different shapes or patterns in the next few videos. Now, there are 5 different shapes that you need to know about, and this will be the last slide of this video. When you describe a histogram or a dot plot, we can discuss its shape or distribution. And here's the first one. You'll probably want to, after I'm done speaking, pause and copy this down. The first shape is the most common shape, called the bell graph or the bell curve. It is symmetric around a middle, and you can see that there's an equal amount on the left that there is on the right. And this is called the bell shaped, and it's centered right in the middle, and most of the data is in the middle. Okay, and again, I'll let you pause and copy that down, and when you're ready, you'll press play. Here's the second one. The second type of shape is a symmetric U-shaped. This is also sometimes referred to as the reverse bell, or maybe inverted bell. And it looks just like the opposite. Most of the data is on the outside of the distribution, and towards the center there's not a lot of data in there. But it is symmetric. Symmetric meaning that if I draw a line down the middle, it folds one half over the other, kind of like a butterfly. And again, pause as you need to copy these down. The third type is skewed right, and that means, ironically, that most of the data is on the left. So that means that the left side is small. So whenever I see the word skewed, I think whatever that side is, that's the small side. And I know that that might not be the way that you know the word skewed in English, but in mathematics, we say that the data is skewed right when it's not symmetric and most of the data is on the left. So it looks sort of like this. If I were to draw a curve, is like the bottom part, whatever part is lowest is which way it's skewing. So if it's skewed right, then the right side is small. And conversely speaking, if it's skewed left, the left side is small. And look at the curve on this one. It looks kind of like this, where most of the data is on the right. This is skewed to the left, which means the left side is smaller. And finally, there's also one called a uniform distribution, where everything is the same. There's no more pieces of data at one side or the other, or in the middle, or on the outside. Everything is just the same. All right, thank you for watching.